Hey, my name's Hayden. This is day 12 of doing Leetcode until I get a job. This is Leetcode 368, largest divisible subset. Alright, given a set of distinct positive integers nums, return the largest subset answer such that every pair of I and j satisfies either of the conditions I divides j or j divides I. If there are multiple solutions, return any of them. Okay. So let's just kind of look at an example here. So one example they give is 1, 2, 4, 8. And the answer to this is just that, 1, 2, 4, 8. This is because if we check, does 1 divide 2? 1 divides 2. Does 1 divide 4? 1 divides 4. Does 1 divide 8? 1 divides 8. Okay, cool. Alright, does 2 divide 4? Yep. 2 divides 8. 4 divides 8. Okay. So we see that each of these element pairs satisfies the above condition. All right, can we extract anything from these examples? It might be harder for some of you, but one one thing to note here is that divisibility is a transitive property, correct? So if A divides B and B divides C, then A divides C. So this basically says that if 1 divides 2, which is true, and 2 divides 8, which is true, then 4 divides, or not 4, then 1 divides 8. Can we all agree on that? So hopefully that makes sense. And this is going to be kind of what we're going to use to leverage in our problem solving here. So let's set up a problem this way. All right, assume that we're trying to solve this problem. Assume that we're going to start with a subset of 8, and we want to find all valid subsets building off of 8. Okay, first we're going to look for anything that divides 8. So let's do 4, because 4 divides 8. All right, that's cool. And then if we want to continue this, so 4 divides 8, that satisfies one condition. All right, let's continue. Does 2 divide 4 and 8? We could check both these conditions where 2 divides 4 and 2 divides 8, or we can use this. So we know that 2 divides 4 and 4 divides 8, so we can say that 2 divides 8 automatically. So this is a very powerful part of the algorithm, which will allow us to build our subsets efficiently. And let's just write this down. And we can change the wording a little bit with this. For any subset A, B, C, if we can add an element D if that element we should make this valid subset. If that element divides the smallest element in the subset, then A, B, C, D is a valid subset. All right, cool. So these two pieces are going to help us solve this problem incredibly quickly. And as we can kind of see from here, this is kind of actually a graph problem where if we continue this, we want to find the largest path, the largest possible path, and that would be our answer. So in this case, 1 to 2 to 4 to 8 would actually be our answer. So if we make this a big like division graph, what is the longest path? Oop, don't want to do that. So let's look at a better example, in my opinion. All right. Let's set up with this example. All right. we have 81. We're going to have to check that 81 does. So 81 is our valid subset at the moment. This is our valid subset. What could be something that divides 81 that we can add? Before that, I'm going to put this in a way that's easy to digest. 1, 3, 9, 27, 81, 2, 4, 12, 36, 72. 72. Let's go here, here. And then we also have an 8 in there. So 4 doesn't just go to 12, it also goes to 8. All right, and then this is part of our graph. There are way more edges, but they're kind of superfluous. So this is just a kind of computational graph that I've created, right? And we can kind of understand it by looking at this part. So we have 81, and then what divides 81? 20. The first element that divides 81 is actually 27. So that's cool. We create a node 27 to 81. And then what divides 27? We look. 9 divides 27. All right. And then we just keep continuing that. And then we're going to want to find the longest path. And we actually do this with dynamic programming. So this is going to be a DP array. And we're going to denote the largest we're going to denote what the largest possible subarray is, which starts at this element. So if we're looking at 81, what's the largest possible valid subarray or subset that contains or starts at 81 and contains all the elements to the right? So in this case, it would be 1, because there's only one element, 81. All right, we look at 72. With 72, we're going to look at all the elements to the right of it and ask the question, does 72 divide any of these? If so, what's the greatest subset which it divides, which can be found down here? So 72. It starts at 1 because it could be itself, or does it divide 81? No. All right, let's look at 36. Okay, does 36 divide 72 or 81? 36 does divide 72, so we could say 36 is the subset of 72 plus 1, so 2. Okay, does it divide 81? No. All right, what about 27? 27, we move along. Does 27 divide 36? No. 27, does it divide 81? Yes. So we go find the value at dp of 81, and then we add 1 to it, so 2. And we kind of continue this pattern. 12 divides 36 and 72, but because 36 is the largest, we're just going to use that. So 2 plus 1, 3. What about 9? 9 divides 27. 9 divides 36. 9 divides 72 and 81. But we're only going to care about the thing it divides at the largest value, which is 27 or 36, whatever you want. So that's 3. 8. Does 8 divide any of these? 8 divides 36 and 72. All right, 3. Okay, then what about 4? 4 divides 8. Yep, 8 has a largest value, 4. All right, 3. What does 3 divide? 3 divides 9. So this is still 4. And then 2 divides 5. And then 1 divides 2, 6. So we've essentially found what the longest subarray starting at that index containing any elements to the right. All right, then the final question is, how do we construct our answer from this? Well, let's move this part for now. And let's move you down. How do we construct our answer from this? Okay, first of all, we know our answer is going to be 6 elements long, so this is our answer array. And we want to first iterate through the DP array and find what the largest index or the largest value was, and it's 6, so that's going to be the length of this. And we're also going to find what index is that was at. So that's going to be our starting point. So our starting point in this is going to be 1. 1 is our starting point. And then we're going to iterate along looking for the next smallest DP value. So we were at 6 before. We want to find a 5 element. We want to, more specifically, not just any 5 element, but a 5 element that divides, or we'll get to that when we get there. All right, so we want to find a 5 element. Oh, we found a 5 element, 2. All right, cool. All right, now we want to find the next smallest. Okay, we're looking for a DP value 4, so we iterate again like this, and then we're like, oh. Or I guess that's a bad way to draw that. Oh, we're at 4 now. This is cool. Let's put in 3. Well, this would actually be wrong. We want to find the next lowest DP value that also has a nums value which is divisible by the previous. So is 3 divisible by 2? No. So we would actually skip this. We're going to go to the next. Does 4 divide 2? Yep, it does. So we're going to have 4. We're going to continue this pattern. Next smallest, we were looking for 3. Does 4 divide 8? Yes, it does. So this would be 8. All right, then we're going to keep looking. 9. Nope, that has 3, 3, 2. Is 27 divisible by 8? No. Is 36 divisible by 8? Yes. 36. And then is 72 divisible by, we're looking for 1. Is 72 divisible by 36? Yes. So 72. And this would be our answer. And if we just look at the code, it's pretty simple. So I just have some extra variables here. I'll explain them. But first, we're going to sort. Then we're going to initialize our DP array. And then we're going to go in reverse order like we did here. We're going to iterate backwards. And then we're going to basically do our whole operation of finding the biggest element that it divides. So like for example 27, or the biggest subset that it 27 divides. 27, the biggest one it divides is 81 plus 1. So that's what this is. The cur num is the num we're on. The next num is the one we're seeing if it is divisible by cur num. And then this is just a temporary variable to track what the largest valid subset we found that it divides. And then if the next num divides the cur num, we see if it's the current max depth, or we try to set the cur max depth either as we're setting the cur max depth as the maximum of itself, or the length of a subset at j, which is the next num. And then after we iterate through and we found the maximum depth or maximum size subset, we will add 1 because we're adding the current elements to it. And then this is just a little bit of help for here, which I'll explain later. And then when we're initializing our answer, we want the longest, or we want our starting point. And instead of iterating to it, I'm storing the longest chain length and the longest chain index. So I can just immediately instantiate this with the starting point, if that makes sense. So the ans is initialized with that, and then the target chain length is just the next element. So in this case, we're looking at, we want 6, and then we want 5, we want 4. So that's tracking what we want to find. And then for I in range, and then we're looking at the next index because that index is already inside, into length of nums. If the target chain lane is the chain length, and our nums element divides the answer, or is divisible by the answer element that's previously in our array, we're going to add the new nums element and decrease the chain. And then if it gets to a 0, we break and we return ands. And if we submit, this goes through. And what's the time complexity on this? Okay, so as we saw, this part where we like went through and then we had to check each element. So we had to go like this, and then this, and then this. This is an O of n squared operation because we have a double for loop in here. So time complexity, at least for this part, time complexity is O of n squared. So time O of n squared. And then coming down here, this is a max of O of n, because worst case scenario is that we're iterating from 0 index to the length of the nums. So total time is O of n squared. Space is O of n, because we're storing this DP array and also our answer. Yeah, this was Leetcode 368.